Welcome back to another AI Practitioner Exam Bite. Reviewing the question from the previous episode asking which AWS service would be most suitable, the answer is C, Amazon Document DB. This is because, firstly, it supports vector search capabilities, allowing for storage and querying of embeddings. Secondly, it's designed to work with document data. And thirdly, it offers MongoDB compatibility, making it ideal for applications that require MongoDB-like functionality. And while other services like OpenSearch, Aurora, Neptune, and RDS for PostgreSQL also support vector search, they don't meet all the criteria specified in the question, particularly the MongoDB compatibility requirement. Okay. Today we're covering the exam objective, explain the cost trade-offs of various approaches to foundation model customization. For example, pre-training, fine-tuning, in-context learning, and RAG. Let's break it down, starting with pre-training. Now, just as a reminder, pre-training is the process of training a model from scratch on a large data set to learn general patterns and representations. Essentially, it's how foundation models are trained. This is the most expensive option as it requires massive amounts of data and computational resources. It can take weeks, months, maybe years to complete, with costs running potentially into the millions of dollars. This kind of thing is best left to specialist model developers like AWS, Anthropic, Meta, Stability AI, to name a few. Next, there's fine-tuning, which involves adapting a pre-trained foundation model to a specific task or domain using a smaller task-specific dataset. This is less expensive than pre-training, but can still be significant depending on how much data you want to use to adapt the pre-trained model. That said, it requires less data and compute time than pre-training, so the cost can range from a few $100s into the thousands of dollars, depending on how much fine-tuning you need to do. This is a good option for customizing models for specific domains or tasks. Then we have in-context learning, which uses examples or instructions within the input prompt to guide the model's behavior without changing the model itself. This is significantly more cost-effective than pre-training or fine-tuning, as no additional model training is required. In this case, the costs are mainly in API calls and prompt engineering time. And finally, we have Retrieval Augmented Generation, RAG, which combines a pre-trained language model with a retrieval system to access external knowledge. We've talked about this in some previous videos. It's a very cost-effective way to customize model outputs, but does require setting up and maintaining a knowledge base. So costs of this include storage, retrieval, and API calls. But it's an excellent way for injecting up-to-date or domain-specific information. Now remember, the best approach depends on your specific needs, budget, and timeline. Consider these trade-offs carefully. Let's do a review question. Which approach to foundation model customization is typically the most cost-effective for quickly adapting a model to specific tasks without requiring additional training? A, pre-training, B, fine-tuning, C, in-context learning, or D, Retrieval Augmented Generation or RAG? We'll reveal the answer in the next episode, where we're going to discuss the role of agents, in particular, agents for Amazon Bedrock. And don't forget to follow, like, or subscribe if you enjoyed this episode, and tell your friends. See you in the next one.